All right, let's go. Number 10. Impossible ring galaxies. In the vast catalogs of deep space, galaxies are supposed to follow a few predictable, well-understood rules of structural evolution. A massive collection of gas, dust, and stars will inevitably be sculpted by the relentless pull of gravity into either a sprawling, flattened spiral like our own Milky Way, or a featureless, elliptical blob of ancient stars. These are the shapes that Newtonian physics and general relativity dictate. But in 1950, astronomer Arthur Hogue pointed his telescope toward the constellation Serpens and discovered something that immediately broke every accepted model of galactic formation. It is now known as Hogue's object, and it is a galaxy that shouldn't exist. When you look at Hogue's object, you do not see a spiral. You do not see an elliptical cloud. You see a perfectly symmetrical, luminous ring of young, violently burning blue stars. In the exact center of this ring sits a dense, spherical core of older, yellow stars. But the true impossibility lies between them. Separating the ancient yellow core from the brilliant blue ring is a gap of utterly empty space, spanning 70,000 light-years across. There are no spiral arms connecting the core to the outer ring. There is no central bar of stars acting as a gravitational bridge. It is simply a disconnected ring of fire circling a solitary golden eye in the dark. According to everything we know about astrophysics, a structure like this should not be stable. Without a gravitational tether or a visible mechanism holding the outer ring in place, the galaxy should have either collapsed inward or flung itself apart billions of years ago. Some astronomers theorized that it was the result of a violent collision, a smaller galaxy punching straight through the center of a larger one, sending ripples of star formation outward like a stone dropped in a pond. But detailed spectroscopic analysis revealed no evidence of a collision. The core and the ring are moving at the exact same velocity, completely undisturbed. Even more unsettling, if you look through the empty gap in Hogue's object, you can see another, smaller ring galaxy perfectly framed in the distance, a cosmic coincidence that borders on the absurd. Hogue's object defies all gravitational mechanics. It stands as a haunting reminder that the universe can assemble structures that our most sophisticated supercomputers and models simply cannot replicate, leaving us to wonder if we are missing a fundamental rule of galactic evolution entirely. Number 9. Giant radio galaxies. At the center of almost every large galaxy lies a supermassive black hole. These gravitational titans act as cosmic engines, consuming matter and, occasionally, blasting out powerful jets of superheated plasma that emit brightly in radio frequencies. We understand how this works. We have mapped these radio lobes stretching for hundreds of thousands of light-years. But in 2022, astronomers discovered a structure named Alcyonius that shattered the upper limits of what we believed the universe could support. Alcyonius is a giant radio galaxy located 3 billion light-years from Earth. The central black hole powering it is actually quite modest by cosmic standards, only about 400 million times the mass of our Sun. Yet, the plasma jets it shoots out extend for an incomprehensible 16.3 million light-years across the cosmic void. To put that scale into perspective, if you place the center of Alcyonius where our Milky Way is, its jets would reach all the way past the Andromeda Galaxy, through the local group, and deep into intergalactic space. It is the largest single structure generated by a single galactic entity ever discovered. This sheer scale presents an insurmountable problem for physicists. A black hole is powerful, but how does it maintain a coherent stream of plasma over 16.3 million light-years? Over such immense distances, the intergalactic medium, the thin soup of particles drifting between galaxies, should have disrupted, slowed, and dissipated these jets eons ago. The magnetic fields required to keep a plasma stream tightly focused across that much empty space simply shouldn't be able to exist. Furthermore, a relatively average-sized supermassive black hole shouldn't possess the sustained energy output to power a jet of this magnitude. Alcyonius breaks our understanding of black hole energy projection. It proves that these dark behemoths can extend their violent influence not just across their own galaxies, but across the foundational architecture of the cosmic web itself, acting as interstellar snipers, firing beams of matter across millions of light years of total emptiness. Number 8. Superpuff planets. When we search for exoplanets, we expect to find variations of the worlds in our own solar system. Dense, rocky, terrestrial planets like Earth, or massive, heavy gas giants like Jupiter. But in the Kepler-51 star system, located 2,600 light-years away, astronomers discovered a class of planets that actively mock the laws of planetary density. They are known as superpuffs, and their existence is a mathematical paradox. Planets like Kepler-51b and Kepler-51c are roughly the size of Jupiter. However, when astronomers measured their mass, the numbers came back so low they thought their instruments were malfunctioning. Despite being the size of our solar system's largest gas giant, these planets possess less than 1% of Jupiter's mass. Their overall density is less than 0.1 grams per cubic centimeter. They literally have the density of cotton candy. This extreme lack of mass creates an impossible scenario. Planets this large but this light shouldn't be able to hold themselves together. They orbit relatively close to their host star, meaning they are constantly bombarded by intense stellar winds and high-energy radiation. A planet with a gravitational grip this incredibly weak should have had its wispy, bloated atmosphere violently stripped away and blown into deep space billions of years ago. It is the cosmic equivalent of a dandelion seed surviving a Category 5 hurricane. Yet, they remain stubbornly intact. Current theories suggest they might be surrounded by an opaque layer of photochemical haze, similar to Saturn's moon Titan, that somehow shields the atmosphere from evaporating. Or perhaps they are currently in a highly temporary, rapid phase of atmospheric loss that we simply caught at the exact right moment. But neither explanation fully accounts for how they formed in the first place. Superpuff planets suggest that planetary formation is far weirder, more delicate, and more absurd than the violent, heavy accretion processes that built our own solar system. They are ghost worlds, spheres of nothingness masquerading as giants. Number 7. Hot Jupiters. In the 1990s, when astronomers finally gained the technology to detect the first planets orbiting other stars, they expected to find solar systems that mirrored our own. Our model was simple and seemingly universal. Small, rocky planets form close to the star where it is too hot for gas to coalesce, and massive gas giants form far away in the freezing depths of space, beyond the frost line, where ice and gas can safely clump together over billions of years. But the very first exoplanet we ever discovered around a sun-like star, 51, Pegasi b, completely destroyed that model. It was a hot Jupiter. Hot Jupiters are massive gas giants, often larger than our own Jupiter, but they orbit blisteringly close to their host stars. While Jupiter takes 12 years to complete an orbit around our Sun, hot Jupiters are so close to their stars that their entire year lasts only 3 or 4 days. They are tidally locked, meaning one side perpetually faces the star, experiencing temperatures exceeding 3,000 degrees Fahrenheit, while the night side is cast in eternal darkness. Their existence is a profound anomaly. A gas giant simply cannot form that close to a star. The intense heat and stellar winds of a young star would obliterate any gathering gas before it could ever form a planet. Therefore, hot Jupiters must have formed out in the deep freeze of their solar systems and then migrated inward. But planetary migration of that magnitude is catastrophic. For a Jupiter-sized planet to spiral inward toward its star, it would have to plow through the entire inner solar system, its massive gravitational field violently ejecting any rocky, Earth-like planets out into the freezing void of deep space, or throwing them directly into the star. The widespread abundance of hot Jupiters across the galaxy reveals a chilling reality. Our orderly, peaceful solar system is not the norm. Planetary systems are chaotic, violent pinball machines where giant worlds ruthlessly bulldoze their way through their neighborhoods. Hot Jupiters prove that planetary survival is a game of chance, and Earth-like stability might be a rare, fortunate fluke in a universe of migrating destroyers. Number 6. Frozen gas giants near stars. If hot Jupiters challenge our understanding of planetary migration, there is another anomaly that outright defies the fundamental laws of thermodynamics. Astronomers have located exoplanets that are situated dangerously close to their host stars, receiving relentless, scorching radiation, yet they possess internal conditions that keep them locked in an impossible, perpetual freeze. The most famous example of this paradox is Gliese 436b, a Neptune-sized exoplanet located 30 light-years away from Earth. Gliese 436b orbits its red dwarf star at a distance of just 2.5 million miles, about 15 times closer than Mercury is to our Sun. At this proximity, the surface temperature of the planet reaches a blistering 800 degrees Fahrenheit. It is close enough that the star's radiation is actively boiling off the planet's atmosphere, creating a massive comet-like tail of hydrogen millions of miles long. By all conventional logic, any water on this planet should exist exclusively as superheated steam. But it doesn't. Deep beneath the scorching atmosphere, the planet is composed largely of water, and that water is entirely solid. It is burning ice. This impossible state of matter occurs because of the planet's immense mass. The gravitational force on Gliese 436b is so incredibly powerful that it crushes the water molecules together with unimaginable pressure. Even though the temperature is hot enough to melt lead, the physical pressure prevents the water molecules from moving or evaporating. They are forced into a rigid, crystalline structure known to physicists as ice-10. If you could somehow stand on the solid surface of this planet, you would be standing on a glacier of ice that is hundreds of degrees hotter than a conventional oven. It is a world where the laws of heat and pressure are pushed to such extreme limits that they create states of matter that cannot naturally exist anywhere in our solar system. Gliese 436b is a terrifying reminder that the universe routinely engineers environments that violate our most basic, intuitive understanding of chemistry and physics. Number 5. Ultra-diffuse galaxies. Dark matter is the invisible, untouchable glue of the cosmos. While we cannot see it, we know it makes up 85% of all the mass in the universe. According to the foundational laws of modern cosmology, dark matter is absolutely required to hold a galaxy together. Without the massive gravitational anchor of a dark matter halo, the rapidly spinning stars of a galaxy would simply fly apart into the void. Dark matter is the mandatory skeleton of the universe. Or so we thought, until we found NGC 1052 DF2. Discovered in 2018, DF2 is an ultra-diffuse galaxy, often referred to as a ghost galaxy. It is roughly the exact same size as our Milky Way, but it contains 200 times fewer stars. It is so faint and transparent that you can look straight through it and clearly see the distant galaxies sitting behind it. But its transparency isn't the problem. When astronomers measured the velocity of the star clusters moving within DF2, they made a discovery that sent shockwaves through the astrophysics community. The stars were moving far too slowly. When you calculate the total mass required to produce the gravitational pull driving those slow-moving stars, the number perfectly matches the mass of the visible stars alone. There is no missing mass. DF2 has exactly zero dark matter. This should be impossible. A galaxy cannot form without a dark matter halo to pull the primordial gas together in the first place. And even if it could, a galaxy this diffuse, lacking the immense gravitational binding of dark matter, should have been effortlessly ripped to shreds by the tidal forces of the massive neighboring galaxies surrounding it. Yet, there it sits, a serene, fragile ghost drifting through a violent cosmos. The existence of a galaxy without dark matter breaks cosmology. It means that either dark matter is not the universal, foundational requirement for galactic formation that we believed it to be, or our fundamental understanding of gravity itself is critically, fundamentally flawed. DF2 is a spectral anomaly that threatens to unravel decades of established physics. Number 4. Black widow pulsars. A pulsar is the collapsed, hyperdense core of a massive star that died in a supernova. These neutron stars are city-sized spheres of degenerate matter that spin at incomprehensible speeds, sweeping beams of electromagnetic radiation across the cosmos like a lighthouse. They are some of the most extreme objects in the universe. But in certain binary systems, these pulsars take on a sinister, cannibalistic nature. They are known as black widow pulsars, named after the spider that devours its mate, and they represent localized environments of pure, concentrated destruction. The most famous is PSRB 1957 +20. This pulsar spins on its axis 622 times every single second. But it is not alone. It is locked in a tight, rapidly decaying orbit with a smaller brown dwarf companion star. The pulsar is merciless. The sheer rotational energy of the neutron star generates a stellar wind composed of high-energy particles and gamma radiation that is so intensely focused and powerful, it is actively blasting the companion star apart. The side of the brown dwarf facing the pulsar is superheated to tens of thousands of degrees, causing its atmosphere to literally boil off into space. As the companion star is shredded, the material is siphoned into the pulsar's intense gravitational well, accelerating the pulsar's spin even further. It is an astronomical execution. The impossibility of the Black Widow pulsar lies in the extremes of its physics. The magnetic fields are trillions of times stronger than Earth's. The radiation pressure is so high, it begins to warp the fabric of space-time around the binary pair. The companion star is being subjected to conditions where atomic structure itself struggles to remain cohesive. We are watching a dead, undead star actively vaporize a living star, stripping it down to a bare, degenerate core before it consumes it entirely. Black Widow systems show us that the universe is not just indifferent to the survival of celestial bodies. In some corners of the cosmos, it is actively and violently hostile, creating engines of targeted annihilation that operate far beyond the bounds of normal stellar evolution. Number 3. Green pea galaxies. When we look deep into the universe, we are looking back in time. Because light takes billions of years to reach us from the farthest edges of the cosmos, looking through a telescope allows us to see what galaxies looked like shortly after the Big Bang. Those ancient, primordial galaxies were small, chaotic, and violently churning out massive, brilliant blue and green stars at an absurd rate. As the universe aged, galaxies matured, settled down, and slowed their star production, becoming the majestic, ordered spirals and ellipticals we see in our local modern universe today. But in 2007, citizen scientists participating in the Galaxy Zoo project spotted something that shouldn't be here. They found tiny, ultra-compact, intensely luminous green blobs floating relatively close to our own Milky Way. They dubbed them green pea galaxies. These objects are incredibly small, only about 5% the size of the Milky Way, but they are producing stars at a rate 10 to 100 times higher than normal galaxies. Their intense green color comes from glowing oxygen gas, superheated by the violent radiation of thousands of massive, short-lived, hyperluminous newborn stars. The impossibility of the green peas is their timing. They are behaving exactly like the chaotic, primordial galaxies from the absolute dawn of time, but they exist right here, in the mature, present-day universe. It makes absolutely no sense. By all cosmological models, the local universe has long since run out of the dense, pristine gas clouds required to fuel this kind of explosive, unrestrained star formation. Finding a green pea galaxy in our cosmic backyard is like exploring a modern, bustling metropolis, and suddenly turning a corner to find a fully functioning Jurassic ecosystem untouched by the passage of time. They are cosmic anachronisms. We have no definitive explanation for why these tiny pockets of the universe seemingly forgot to age, suspended in a state of violent, primordial youth while the rest of the cosmos grew old and cold around them. They are a glitch in the cosmic timeline. Number 2. Giant cosmic arcs. To understand why the giant arc is so terrifying to astrophysicists, you have to understand the foundational pillar of modern cosmology, the cosmological principle. This principle states that, when viewed on a large enough scale, the universe must be homogeneous and isotropic. That means, no matter which direction you look, the universe should look essentially the same. Matter should be evenly distributed in a uniform, random web. According to the mathematics of the Big Bang, gravity has only had 13.8 billion years to pull matter together. Therefore, there is a strict, hard mathematical limit on how large a structure can be. Nothing in the universe should be larger than 1.2 billion light-years across. It is simply physically impossible. Then, in 2021, astronomer Alexia Lopez presented her analysis of the light from distant quasars. mapping the absorption lines of magnesium to reveal the hidden structure of galaxies in the deep universe. What she found broke the cosmological principle entirely. She discovered the giant arc. The giant arc is a perfectly symmetrical crescent composed of densely packed galaxies, galaxy clusters, and massive amounts of gas. It spans a staggering 3.3 billion light-years across the observable universe. It is nearly 3 times larger than the absolute maximum size limit allowed by the laws of physics. A structure this massive and this defined implies that the universe is not random. It is not evenly distributed. The universe is lopsided. How does a continuous, symmetrical arc of matter, 3.3 billion light-years, long form? It shouldn't have had enough time to pull itself together since the dawn of the cosmos. Furthermore, the arc is not alone. We have begun finding other impossibly large structures, like the giant ring, which spans 5.6 billion light-years. The existence of these hypermassive structures suggests that our fundamental assumption about the universe, the cosmological principle, is completely wrong. If the universe is not uniform, then our models for how the universe expands, how dark energy works, and how gravity operates on a macro scale are all fundamentally flawed. The giant arc is a structural impossibility that forces us to realize we might not understand the basic architecture of the universe at all. Number 1. Hercules-Corona Borealis Great Wall. If the giant arc threatens to break cosmology, the Hercules-Corona Borealis Great Wall actively shatters it. Discovered in 2013 by astronomers mapping the locations of gamma-ray bursts, the most violent and luminous explosions in the cosmos, this structure is the absolute largest known entity in the observable universe. It is a vast, dense filament of galaxies bound together by gravity, and its dimensions are so extreme they defy human comprehension. The Great Wall spans an unimaginable 10 billion light-years across. To understand the absurdity of this number, you must look at the age of the universe itself. The accepted age of the cosmos is 13.8 billion years. Light, the fastest thing in existence, takes 10 billion years just to travel from one end of this galactic structure to the other. It occupies roughly 10% of the entire diameter of the observable universe. The existence of the Hercules-Corona Borealis Great Wall is a logical paradox. Gravity operates at a finite speed. For a structure of this immense density and scale to coalesce, pulling trillions of galaxies together into a unified filament, it would require tens, perhaps hundreds of billions of years of gravitational attraction. The universe is literally not old enough for this structure to exist. It is a mathematical impossibility. Its mere presence suggests one of 2 terrifying conclusions. First, the theory of general relativity and our understanding of how gravity shapes the cosmos is entirely incorrect on large scales, operating by rules we haven't even begun to formulate. Or second, and far more unsettling, the Big Bang Theory itself is wrong. If a 10 billion light-year structure exists, the universe might be vastly, unfathomably older than 13.8 billion years. The Great Wall stands as a monolith of our own ignorance. It is an impossible monument floating in the dark, silently proving that the deepest foundations of our science, our timelines, and our understanding of reality itself are incomplete. We are staring into the abyss of the cosmos, and the cosmos is showing us a structure that dictates everything we thought we knew is just a fraction of the truth.